Okay, welcome to my presentation of proof 1.2. This one is about the expectation of x bar and the variance of x bar. So just as a reminder, x bar is defined as 1 over n. So xi as the sum of our xi's, we have n of them, and then we average them. And according to the prompt here, we have n IID random variables, so they're independent and identically distributed, or actually it doesn't even say that they're identically distributed, but it does say that they have the same mean and independent, and their mean, so the expected value of each xi is equal to mu, and the variance of each xi is equal to sigma squared. Is equal to sigma squared. Okay, so it's a two-part proof. The first part is where we want to show that the expectation of x bar is equal to mu. Okay, well, take the expectation of 1 over n, the sum and what's that equal to? Well, we use the linearity of our expectation operator to say that is equal to 1 over n, and then so we take 1 over n out, but then we can split this up as well by linearity, so we end up with sum over all of these over the expectation of all of these xi's. Well, we already said that the expectation of each xi, the mean of each xi, is mu, so this is mu in every case. And we're summing up n of them, so the whole thing is equal to 1 over n, and then we have our n mu's. Well, the n cancels with the n, so we are left with just mu. So the expectation of x bar is equal to mu, as we wanted to show. The second part of the proof asks us to show that, one second here, so part 2 of our proof asks us to show that the expectation that the variance of x bar is equal to sigma squared over n. Well, that is the variance of 1 over n, and then the summation of all of our times the summation of all of our xi's. We have n of them. Well, we know that when we multiply a random variable by a number, its variance is the variance of that random variable times the square of whatever number we multiplied it by, so we end up with 1 over n squared variance of the sum, just the sum of our random variables. Right? And here is where independence comes in. So we know that for independent random variables, the variance of their sum is actually the sum of their variances. So we end up with 1 over n squared and then times sum of all of their variances. But recall that we are given the variance of each one of these xi's is in fact the same. It's sigma squared. And then we sum over them, so we get n of them, so that is equal to 1 over n squared times n sigma squared. Oh, we get cancellation there, so we are just left with sigma squared over n. And we are done. Remember what that is. That is the variance of x bar, and that is exactly what we wanted to show. So we have completed this proof.